Hello, good afternoon, everyone. So today we'll be talking about suite of developmental characteristics. So in our last lecture, we talked about gastrulation, which is a process whereby there is a rearrangement of cells to give rise to three germ layers, which includes the endoderm, the mesoderm, and the ectoderm. So, and I told us that we can either have a diploblastic animal or triploblastic germ layer, sorry. Where we have for the diploblastic, we talk about the animals that have only endoderm and ectoderm, while the triploblastic animals that have the endoderm, the mesoderm, and ectoderm. So today we'll be looking at the suite of developmental characteristics of triploblastic animals. Now, these triploblastic animals can either be protostome or deuterostome. So, and the four developmental characters include radial or spiral positioning of the cell as they cleave, regulative or mosaic cleavage of cytoplasm, fate of the blastopore to become mouth or anus, and schizocolus or enterocolus formation of the xylem. So we now look at example of each of them. For example, the protostome example include the snails, the earthworm, etc. While for the deuterostome, look at the star, the sea star, the fishes, and the frog. Okay, so let's look at the developmental, the deuterostome development. Okay, so for the deuterostome development, we talk about the cleavage pattern, and I said that deuterostome is bit radial cleavage, and this is because the embryonic cells are arranged in radial symmetry around the animal vegetal axis. It's important to know this because in exam I can ask us to list the four major developmental characteristics of a diploblastic animal, of triploblastic animal, or I can tell us to, in a tabular form, differentiate between protostome and deuterostome of triploblastic animal. So these four things: radial or spiral positioning of the cell as they cleave, regulative or mosaic cleavage of the cytoplasm, fate of the blastopore to become mouth or anus, and finally the schizocolus or enterocolus formation of the xylem. So, having talked about the cleavage pattern of deuterostome being radial cleavage, and then that the embryonic cells are arranged in radial symmetry around the animal vegetal axis. Then we'll look at the regulative cleavage of the cytoplasm, and I said that most deuterostome have regulative development where the fate of the cell depends on its interaction with neighboring cells. Now, rather than on what piece of cytoplasm is acquired during cleavage, in this embryo at early in development, each cell is able to produce an entire embryo if separated from the other cell. In other words, each cell is independent of the other cells, so that even when they are separated from the other cell, they can still, at the end of the day, be able to produce that which is meant to be. Now, if a blastomere is removed from an entire embryo, the remaining blastomeres can alter their normal fates to compensate for the missing blastopore and produce a complete organism. And this adaptability is termed the regulative development. So this is why we call it the regulative development, because if a blastomere is removed from an early embryo, the remaining blastomeres can alter their normal fate to compensate for the missing blastomere and produce a complete organism. So there will not be the formation of the organism if a blastomere is removed or detached from an embryo. Talk about the third one, which is the fate of the blastopore to become mouth or anus. And I say that the blastopore becomes the anus, and the second unnamed opening becomes the mouth. Then for the enterocolus formation of the xylem, in enterocoli, both mesoderm and xylem are made at the same time. In enterocoli, gastrulation begins with one side of the blastula bending inward to form the achanteron, or what we call the gut cavity. Now let's look at the protostome development. I say that here the development cleavage patterns is spiral cleavage unlike what we have in Deuterostome, which is what? Radial cleavage. And I say that the two it differs from radial cleavage in two important ways. One is that rather than dividing parallel or perpendicular to the animal vegetal axis like the Deuterostome, blastomere cleave obliquely. They cleave obliquely. They do not divide parallel or perpendicular to the animal vegetal axis. Then for the mosaic development, in Deuterostome we have regulative cleavage of the cytoplasm, while in the Protostome we have mosaic development. In mosaic development, characterize most protostome. Here, the cell fate is determined by distribution of certain protein and messenger RNAs called the morphogenetic determinants in the egg cytoplasm. While in Deuterostome, there's nothing like that. In Deuterostome, the fate of a cell depends on its interaction with neighboring cells, unlike what is found here, that the fate of the cell is determined by distribution of certain protein and messenger RNA called morphogenic determinants in the egg cytoplasm. Also, for the protostome, when a particular blastomere is isolated from the rest of the embryo, it still forms the characteristic feature decided by the morphogenic determinant it contains. And then, in the absence of a particular blastomere, the animal lacks those structures normally formed by that blastomere, so it cannot develop normally. Unlike what we see in Deuterostome, whereby even if a blastomere is removed from an early embryo, the remaining blastomere can alter their normal fate to compensate for the missing blastomere and produce a complete organism. So here, they do not produce a complete organism. They will now have what we call the formation of that organism. And this pattern is called mosaic development because the embryo seems to be mosaic of self-differentiating parts. We look at the third one, which is the fate of the blastopore. I said that a prostomere is so named because the blastopore becomes the mouth, unlike the Deuterostome, where the blastopore becomes the anus. Here, the blastopore becomes the mouth, and the second unnamed opening becomes the anus. So the opposite of what is happening here is what we found in Deuterostome. So we'll talk about the xylem formation by schizocoely, while in Deuterostome, xylem formation is by enterocolous. Okay, in Protostome, a mesodermal band of tissue surrounding the gut formed before a xylem is made. But in Deuterostome, both mesoderm and xylem are made at the same time. Both of them are formed at the same time. But here, you find out that the mesodermal band of tissue surrounding the gut forms before the xylem is made. And the inner xylomic cavity is made by schizocoely, unlike Deuterostome, which is made by enterocoely. So, in your free time, you can just get your pen and summarize these notes. You can do it in a tabular form. You write the other side, one side will have protostome and the other side enterostome. So you have to compare it equally. It's not when you are talking about the first one, which is radial development, development in terms of the cleavage. You will now be talking about regulative cleavage in the other one. So you have to compare it equally. When you are talking about the cleavage pattern of Deuterostome, you also talk about the cleavage pattern of the protostome. So in exam, if I ask differentiate between the protostome and Deuterostome, you just put it in a tabular form for easy and straight to the point answer. Okay, so we are going to be I'm going to be giving us assignment. So our assignment will be to read up on problems in animal development. You don't need to submit it. Okay, I can ask us in exam list 3 problems in animal development. Problems in animal development. One of them is cell death, or what we call apoptosis. Okay, cell death is an unavoidable event that happen in animal development. Cells, 80% of cells used to die, and then some regenerate, and this have an advantage in cell development. So let's find other problems that can emanate in animal development. So I want this video to be short. Thank you for watching. And the next time I come to class, we'll just do revision. If you have question, you can just write your question on the comment section, or you can reserve it for me. When I come to class, we can discuss them. Having said this, this is a last notes for this zoo 315. So I have covered my part, and that's it. We'll see in the exam hall. I believe I will come again for revision. But if you do not have any question, and if you perfectly understood the videos and the lecture notes, then maybe there's no need for us to meet again. Having said this, I will see you people later in the exam hall or in the class. Thank you for watching.